Hello class, today we're going to focus on basic trig equations, which basically means we're going to continue doing what we've been doing, but add a little bit of another step per se to do some algebra before getting to solving any single trig function. So for this question we're solving for theta within the interval. Maybe this might not be given in the future, but just to say that this is the given interval and we have to solve for what theta is within this interval. And here's the question. Sine theta is equal to negative root 2 over 2. Take a moment to see if you can answer this, and we'll continue in a second. So to start solving this, you might want to realize that without a calculator, and most of my questions are without a calculator, that this here is going to be one that you should have memorized from a table or your unit circle. So if we're going to draw our unit circle really quick as a reference guide, I'm going to just refer to quadrant 1 since it's repeatable, that we have our 5 major points, one along the x-axis, the horizontal axis, one here for a smaller triangle, one here for a middle triangle, one for our larger triangle, and then one along the vertical axis. And then if we draw our little triangles to represent this, we have all these different points that we should refer to. Now, the biggest thing that we should notice is that root 2 over 2, that's going to be our middle point. So here, it's going to be root 2 over 2, and this is going to be root 2 over 2 as well. Our middle point is represented, or middle angle I should say, is represented by this triangle here, and the angle to the horizontal axis is actually going to be referring to our, or we're going to refer to it as our reference angle. In this case, it is pi over 4. The reason why we're calling it our reference angle is we have to pay attention to this negative here. So this is not our final answer. This is our reference angle for each other quadrant. So if I were to draw those other quadrants, remember it's negative, so we have to have a y that's negative. That's going to be quadrants 3. So we have a terminal ray here. That's going to be 1 theta, and then we're going to have here another one. I'm going to offset it slightly so you can see the rotation. Here, you're going to have another one. So we have 2 different thetas. 1 theta will be in blue. This one is going to be your half rotation plus alpha. So that's going to be pi plus pi over 4 here, which equals 5 pi over 4. So that's 1 theta, and we're going to do the other theta, being that it's just beyond this. If this was 0, this was pi over 2, this is pi, this is 3 pi over 2. So you have 2 ways of doing it. You could say 3 pi over 2 plus pi over 4, or simply look at the remainder and say what's left over, since it's the halfway point. But actually, let's just stick with 3 pi over 2 plus pi over 4. I think that'll be the safest bet. Here, if you add these together, you will get 7 pi over 4. And feel free to verify that. So those are our answers for this section here, solving for theta. And that's perfect. That gives us exactly what we want. Before moving on, though, I want to show something that, remember that solving for theta means you're actually doing something we've been doing this whole time, but we just learned this recently, that an inverse function, right, your arc sine, is going to be taking a ratio and you're asking for theta. Well, to be honest, that's like doing this. Now, some of you may say, oh, I should have done this immediately and tried plugging this in my calculator. You won't get the same answers. And the reason why you won't is because, remember, the inverse sine function, you're restricted to two quadrants. Quadrants 1 and quadrants 2, and it's measured from 0 to pi over 2, and from 0 to negative pi over 2. Rather than the way we've been doing it here on the unit circle notation here, where it only goes counterclockwise. This is going clockwise and counterclockwise. If you wanted to use your inverse function to solve for this, you should have actually rewrote it instead of in this fashion. So let's point it out. Instead of here, the negative should have been notated as negative sine inverse of root 2 over 2. And this doesn't give you theta, it gives you your alpha. And then you can take your alpha and plug it into, I'll plug this, into these formulas here. So you take, undo, you take this here, and you plug it into these little equations here to get the thetas for the other quadrants. So for this next problem, we're going to solve for theta in degrees, but we're going to try to give all solutions here. We're reading the directions to say this is not an interval question now, this is all solutions. That changes our answer quite a bit, and we'll go through that in the very end. But the big thing to note is that this question here, part A, is saying root 3 cosecant of, oh, forgot theta in there. Gonna have to move that. Separated that bit out. Let's just use that. Theta minus 2 gives you 0. So take a moment to try and solve that on your own. Now if you are frozen with this, that's okay. But I want you to understand that really, really important, this is actually not too different from what we normally handle. It's just in an algebraic expression. So we can actually solve it by simply saying, okay, well, we have multiplication and addition here. I'm going to add 2 to both sides to get rid of the 2. Because I can't just look for theta right now. I have to do something to this equation to make it look better. Now I'm going to get root 3 cosecant theta equals 2. And then divide by root 3. Cancel that out. Divided by root 3. And you're left with cosecant theta equals 2 over root 3. And we're not done yet. We're going to keep going. Because we can't use cosecant the way it is. It's a reciprocal of our sine function. So sine theta equals root 3 over 2. Now this is something we can use, something we're more used to. Sine theta is going to be equal to this root 3 over 2, but remember, you might say, well, our reference angle, so I'll use this in green, our alpha is going to be equal to, and if you remember your unit circle, remember when in doubt draw it out, is going to be our larger angle triangle, meaning that this is going to be, in this case, we said in degrees, so we're going to look for 60 degrees, and that's our alpha. But that does not satisfy giving all the solutions. So we should note that this occurs, this value of root 3 over 2 occurs whenever the angle is back to its reference angle of 60 degrees. So if we start off looking at our angles at all, we're going to get that our first 60 degree angle is going to be root 3 over 2. So we actually can say every single rotation after the fact, full rotation has to go back to 60 degrees, it's going to be, again, root 3 over 2. So we can actually say that 60, we're not going to write degrees yet, and I'll show you why, plus 360, so that's another full rotation, times n in degrees, that is an equation for solving any specific solution, basically depending on whatever interval you're given. So this will work for any interval. It just will spit out whatever number you want to fit in that interval. The thing is, we have another point that exists, because remember it's root 3 over 2, that's positive. We're assigned positive. Well, we have two different quadrants. We have the first and second quadrant here. We have to now find what it would be on the other side. So here we would take 90 plus 60 to get your full angle, which equals 250 degrees. So now, I'm going to keep this in blue, we have 150 for our equation plus 360n, and all of this is in units of degrees. And then this here is your answer. Alright, so let's try another one. In this case, I want you to try it on your own again and try to see that 5 cosine theta plus 6 is equal to 1. So, take a moment and try it out. Remember, you don't need a calculator for this. Alrighty, let's give it a go. So the first thing you want to do is make sure you move everything to one side before you do your trig function, or your inverse trig function. So you're going to do minus 6, minus 6. You're going to get 5 cosine theta is equal to negative 5. And then you're going to divide by 5, divide by 5. Actually, I should show that crossed out. Same here. And here you're going to get cosine, let's do my little arrow. Cosine theta equals negative 1. So here we have to find a solution for whenever cosine theta is going to be equal to negative 1. Again, if we want to look at what that would be, if you wanted to quickly use a reference guide of the unit circle, the negative 1 only happens at one point where your x is actually negative 1, and that is at pi. So now we need a solution to say whenever pi occurs, or you get back to this point, this terminal ray gets back to this specific point here, which is your reference of pi, that will be your answer. And I must say I misspoke. I have to read my directions. This one here, solve for in degrees. So I actually have to get rid of this and say that this is 180 degrees. So actually, it's going to be a very simple formula for this. It's going to be 180 plus 360n, because remember, that's going to be our full rotations in degrees, and that is our answer. Not too bad. Well, this video turned out a little bit longer than I was hoping for, but I hope it was overall being a helpful experience for you. Look forward to seeing you all next time, and feel free to email me or contact me if you have any questions. Take care.